Hello everybody, today we are going to be solving this limits question and it's a very interesting question. I could not solve it in my first try and it's like a kind of a complex question you can say. Okay, so it requires you to apply a lot of brain and it's not an easy one. So let's get started. Now this limit is extending to 0 and we have given x raised to power 6000 minus sine x raised to power 6000 upon x square into sine x raised to power 6000. Now as you can see, this is 0 by 0 form, so we can think of applying the L'Hopital, but after 1 minute of thinking you are going to figure out that that won't work. Why? Because differentiation of this will give you 6000 into x raised to power 5999, which will, when extending to 0, this will also tend to 0, and differentiation of this using chain rule will also have the term of sine x, right? It will always have the term of sine x, right? So no one is dumb enough to like differentiate it 6000 times, so L'Hopital won't work over here, right? So we have to think of something else, and let's see what we can do. Now first what we can do, we can satisfy the denominator, that is like bringing this term in the sine x by x form, because when x tends to 0 then sine x by x tends to 1. Okay, so we can say limit of x tending to 0, we can multiply x raised to power 6000 and divide x raised to power 6000, so we have x raised to power 6002 into sine x by x raised to power 6000, right? And in the numerator also we can take out x raised to power 6000 common, so that will give us 1 minus sine x by x raised to power 6000, right? So we have this. Now we can see that x raised to power 6000 and x raised to power 6002 will cut and we'll have x square in the denominator. So what does this limit become? It becomes limit x tending to 0, 1 minus sine x by x raised to power 6000 upon x square into sine x by x raised to the power 6000, right? So this is what our limit becomes. Now we can see this x squared term is troubling us. Why? Because even if this tending to 0, this will give 1, this will give 1, but x square in the denominator we still have 0, right? And we do not want that. So how are we going to get rid of it? We are going to apply the expansion of sine x. If you remember, I also haven't like properly remembered these expansions, but sine x expansion is x minus x cube by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial and so on, right? So this is the expansion of sine x. Now we have sine x by x over here. So sine x by x expansion whole divided by x, so we will be going to be left with equals to 1 minus x square by 3 factorial plus x4 by 5 factorial and so on. But what we do, we know that when we expand, we just need the term till the power of the denominator. So like if we have x square in the denominator, then we just need the x square term, the first term having a power greater than or equal to the denominator. So x square by 3 factorial is the such term which has the equal term as equal power as in the denominator. So we are going to expand only till here. So what will sine x by x become? It will become 1 minus x square by 3 factorial that we are going to use over here. Okay, so I'll just clear all of this up and I'll just, how do I move this in the trash can? Okay, getting used to this iPad. Okay, so now what we are going to do, we are going to apply the expansion. So we'll get limit x tending to 0, 1 minus x square by 3 factorial over here. This is whole raised to power 6000 upon x square into sine x by x raised to the power 6000. Okay, now this expansion will be very big, so we are going to apply the binomial expansion. As we have seen, this is in basic maths also. When 1 plus x raised to the power n is such that x is tending to 0, then this expansion becomes 1 plus nx, right? So we are going to apply this expansion, binomial expansion, that this thing over here will become limit x tending to 0, 1 minus whole of 1 minus 6000 into x square by 3 factorial, that is 6, upon x square into sine x by x raised to power 6000. Okay, now we are just going to open this up. This is becoming 1000 and 1 minus 1 0, and this will become 1000 x square upon x square sine x by x raised to power 6000. This whole thing will become 1, right? So the answer is 1000. So this was this question, very interesting question. Here we need to remember the two results. One was the sin x expansion. The question is over, but I can tell you the expansions of every, like, basic expansion. So sin x becomes x minus x cube by 3 factorial plus x5 by 5 factorial, and so on. Cos x becomes 1 minus x square by 2 factorial plus x4 by 4 factorial minus x6 by 6 factorial, and so on. E raised to the power x becomes 1 plus x square by 2 factorial plus x cube by 3 factorial, and so on. And log of 1 plus x becomes log of 1 plus x was x minus x square by 2 plus x cube by 3 minus x square by 4, sorry, x4 by 4 plus x5 by 5, and so on. All right, so these are the basic expansions, and also the result. This result is very important. 1 plus x raised to power n, when x tends to 0, then this becomes 1 plus nx. Okay, so this was the video, guys. I hope you like the solution of this question. Wasn't very intuitive at first, but you'll get the hang of it, like I may. So thank you, guys, and I'll see you in the next one.